Hi, this is my video for Chem 101 Lab, all about calorimetry. So let's get started. Calorimetry is the science of measuring the heat absorbed or released during a chemical reaction. This number is usually measured in joules or kilojoules, depending on which is most appropriate. It makes use of a calorimeter, a device that specializes in measuring the temperature of the surroundings, which then allows us to figure out what the temperature of the system and therefore the heat exchange between the surroundings and the system, something we'll get into a little bit later. To go into more detail about what a calorimeter is, I have three examples. On the left, we have a bomb calorimeter. On the right, we have just a very technologically advanced calorimeter. In the middle, we have a very simple one that we utilize in our labs. The basic components of a calorimeter is that you insulate heat, so that the heat given off by the reaction or maybe given to the reaction, it doesn't escape into the air. It has some sort of stirrer usually to make sure that the reaction is continuous while we are recording temperature. And of course, it has a thermometer to make sure that we are recording the temperature of the overall reaction. The data that we collect during the process of calorimetry using the calorimeter is actually super helpful because it allows us to understand more about the chemical reactions, either keeping track of them by figuring out when the heat exchange begins. It can help us determine what type of reaction it is, and it can also help us figure out the overall heat energy of a reaction using the equation Q equals MCAT, where M is mass in grams, C is specific heat of the molecule, and change of T is T initial minus T final, all in degrees Celsius. If Q is a negative value, that means it's an exothermic reaction and the system gave heat energy to the surroundings. If Q is positive, then it's an endothermic reaction and surroundings gave heat to the system. But there are some problems with calorimeters. The first thing is that just basic lab safety when you're dealing with acid and bases and doing a neutralization reaction in the calorimeter, you have to be careful to minimize exposure. So that means wearing gloves, wearing long sleeve, long pants, closed-toe shoes, and your lab coat, and of course, goggles. You could also accidentally spilled your solutions on electronics, which can be very bad. And another thing is that not every reaction can be tested with a calorimeter. Sometimes they are not compatible. Another thing is that we want to keep the stirrer away from the thermometer in the calorimeter, or it could interfere with the temperature measuring. When calculating enthalpy, we have to keep in mind that energy is not only given to the surroundings, but also the calorimeter itself. But to account for that, usually you'll spend some time finding calorimeter constant, which you'll also subtract from the temperature you find. And then another thing is that the transfer of heat energy is not instantaneous and it does take time. A lot of times we make use of a cooling curve using early data points to figure out the exact moment that enthalpy exchange began. And that is calorimetry, and I hope that made all made sense. Thank you for watching.